We are working on expanding our ecosystem for both MCUs and DSCs. We are expanding our development tools as well as expanding the tools to support model-based design so that we can cater to these emerging trends in the market.
On this episode of Embedded Insiders, we're defining the architectural differences between MCUs and DSCs with Microchip Technologies Product Marketing Manager, Pramit Nandy. We also dive into the different processing capabilities, the challenges for designers, and what we can expect as far as emerging trends and technical developments for Microchip. Next, Rich and Dr. Moritz Neukirchner, Senior Director of Strategic Product Management for Software-Defined Vehicles at Elektrobit, joins us in the next installment of Scoping Out the Software-Defined Vehicle to discuss his thoughts on open source and software-defined vehicles and what's necessary for further advancements of both open source and automotive industries. But first, Ken and I are discussing the Matter open source connectivity standard for smart homes and IoT devices. Hello, and welcome to the Embedded Insiders podcast. I'm Associate Editor Tiara Oliver at Embedded Computing Design, and I'm here with Ken Briota, Senior Technology Editor, and Rich is not here with us this week, but he'll be back next time. Fingers crossed. Let's hope.
And he's dearly missed, probably not
Yeah.
least of all by our listening audience. Hi, Tiara. How are you?
I'm good. So you came up with our intro topic this week.
I really wanted to talk about something that matters.
Ooh.
I've been thinking a lot about interoperability and especially in smart home because I've had some great conversations with Silicon Labs actually, and we've been talking about Matter, which is this really powerful, interesting standards protocol for interconnectability between a bunch of different kinds of devices, mostly being used for the smart home, but I think that it's very likely got the chops to sort of expand out of the smart home once the case gets proved at scale, because it's still rolling out. I think it's fair to say, but it's really cool stuff. The reason I was talking to them recently is they've and there's a story coming out soon about this on embeddedcomputingdesign.com for those of you who need to check that out. But they've partnered up with a smart lock manufacturer called Nuki out of Austria, and they're going to be using Silicon Labs and solutions, and specifically Matter over Thread in their smart locks. That is really interesting because obviously it allows them to be interoperable with other smart home tech, and they're going to have fingerprint unlock. It's going to be really, really cool. So that's sort of why it's been on my mind.
I'm glad that you brought it up again. I feel like for me, Matter is something that pops up every couple months and then it goes away. I know it's still in the works of being officially launched, but when you mentioned this, I had to go online and see what was happening in the news, and there wasn't very much as far as like recent updates. And I was a bit surprised that there hasn't been much talk about it, at least this year.
Yeah, there was a bunch of stuff about it at CES when Rich and I were there. But yeah, it's funny, the smart home. I think I've mentioned on the show before. I've been writing about IoT for a long time, and smart home specifically has had such a failure to launch, such a hard time getting off the ground. And I think, I don't have a lot of data that isn't anecdata about this, but I think that a lot of that has to do with users and, the homeowners and stuff who would be responsible largely for self-install on these things because they're not getting put in with original construction on most homes. And so most people aren't paying somebody to come out and install, so it's self-install. And because there hasn't been any unified standard for connectivity specifically, uh it's really hard for these people to figure it out. None of them is a sysadmin and none of them want to be. so so I think that's been a lot of the holdup with the smart home. People have also had a lot of security concerns around it, but uh,
Yeah.
that seems to be mostly intellectual talk because I feel like nobody in their real life ever thinks about it.
That's true. I think when I think about implementing a standard like this into the homes of most people today, it's kind of like, well, they have their smaller devices, their Alexas, their Google Homes and Ring cameras, but I mean, I feel like it's a very slow adoption even for
Yeah.
that. You kind of see where other people have it and how they use it, and then you're like, "Oh, maybe I'll get one," but I think
Yeah.
we just need to see more people, the first couple of people when it comes out, using it and how they're using it, and then maybe, depending on how it's advertised, a whole rush of people will go in.
Yeah, absolutely. I mean, I'm probably in the early adopter camp when it
Mhm.
comes to technology stuff. And I have had a sort of smart home setup for several years. But it's mainly for lights, and
Mhm.
like a couple of my TVs are hooked into hubs around the house. I actually within the last year changed who where which hub brand I was using. I don't know if I'll call them out, but one of them absolutely deteriorated in usability.
Mhm.
So I switched to another of the major brands, and I won't call them out because they were a little bit older models because I early
Mhm.
adopted, but the interoperability was absolutely a struggle even for me. And so that's part of why I'm excited about Matter. I think Matter solves those problems well. I saw a really interesting smart home demo in when I was at CES. It was really, really cool. The sensing presence in terms of like who's present in the room and what settings do they want that was enabled. There's a bunch of really cool sort of futuristic stuff that you sort of think about as smart home when you think about smart home, right? It was really, really, really cool, and I was really encouraged by it because I think that the idea of smart home has to get easier in order for it to actually like have market penetration, or it's just not gonna work.
That actually brings up, like, another point that I was thinking about when I was looking online about this, because I did see a few forums and other online conversations where people are still asking, like, "What can Matter do for me?" or "What can it give me that I don't already have?" So
Right.
I think we do have some of the use in the devices we have now, but maybe it's the more customizable aspect of it.
Yeah, I think so. I think that it's not only the customizability of it. Is customizability a word? I don't know. I made it up. Enjoy.
Yes.
In addition to that, it's also that the ability that it has to sort of make it not matter what brand device you're using. So long as that device is Matter compatible, which uh, obviously, we need the OEMs to all get on board with this, but I think they are starting to see the advantages here. Then the homeowner doesn't have to be like, well, I have to buy all GE devices, and then
Mhm.
I have to use a hub from whoever, and all that stuff. Oh no, is this all Zigbee? I don't know what Zigbee is. Like, because like most of these people are not going to know what that is. So like, that's why they struggle and it doesn't work, and then they stop using it. They just get rid of it in a shocking number of cases. So I
Mhm.
think that it's got like you said, that sort of it's got to be customizable, and I think the advantage also is that it's going to be sort of device agnostic. It's that like universal translator type of protocol that will let
Yeah.
you use your TCL TV and your GE smart bulbs and your Ring lock and whatever Google Home Smart Hub you want, and it won't matter.
Mhm. Well, when this, officially comes out, do you think it's something that you'll personally use?
I'll be looking for it, absolutely, I think. My current suite of devices are not Matter compatible.
Mhm.
So, I'll have to do a turnover at that point, but, well, my hubs are actually, um, and that, of course, is a whole nother problem, is that all of this stuff, despite the fact that it is a cost savings over time, initial buy is always a little bit pricey.
Yeah.
But that's not a Matter issue. That's a OEM's issue, a smart home issue. Um, and that's why I think that if everybody was thinking only about the end users and about adoption, we'd be
Mhm.
selling smart home packages to new home and building construction and trying to make it part of new construction rather than asking it for it to be aftermarket. I think that would ease a lot of issue, but at least here in the US, new home construction is such a small portion of the real estate market that
Yeah.
that I'm not sure how much that would help, but I think it would get the ball rolling in a good way. But it's
Yep.
also not the most revenue forward way to do it. So
That's true. It seems like it would make a lot of sense to do it that way, though. But I know, or at least in my opinion, I think you and Rich are fairly techie and you guys implement, some of these things in your daily lives. So I hope maybe when it comes out, either one of you start using it or getting into it because I'm honestly curious to see.
I'm sure. Look, Rich is going to be so salty that we had this conversation without him because he loves this stuff, and
Oh, yeah.
I'm looking forward to him absolutely making us talk about this again in the future because I know he's a big fan of smart home and those kinds of gadgets.
Yeah. I'm hoping some more news is coming out soon so then he can definitely join in on the conversation.
Absolutely. And for you folks out there listening, if you want to join in on the conversation, make sure that you're following us on our social medias and reading all of the matter and other news online.
Now, here's Product Marketing Manager Pramit Nandy of Microchip Technology giving his professional and technical expertise on the capabilities of MCUs and DSCs.
Pramit Nandy, and I am Product Marketing Manager here in Microchip. I am in charge of the DSPIC DSCs here in Microchip, which is basically a digital signal controller. I have about 15 plus years of experience in the field of control systems, instrumentation, analog IC design, application, as well as a system architect, managing different products, whether it's analog or microcontrollers. And now I'm in marketing role for last actually 7 years now, after being in the technical field for a while.
Can you start by telling us maybe what are the key architectural differences between MCUs and DSCs?
Sure. So MCUs and DSCs, both these devices, they serve distinct functions within the embedded systems. They are used in various applications, whether it's automotive, industrial, aerospace and defense, consumer, medical, and so whatnot. You might find it everywhere, even in your wearables. But in terms of architecture differences, the purpose of the core is different, right? So for MCUs, which are generally designed for general purpose application, which are more oriented for simple control-oriented solutions, like interfacing with sensors, controlling some actuators, or reading some data out and managing data. The digital signal controllers, on the other hand, they are optimized for high-speed numerical computation. So they excel in doing digital signal processing tasks, such as doing fast Fourier transform, digital filtering, control algorithms for motor control or digital power. So if you look at the architecture, so MCUs are a little simpler compared to digital signal controllers.
So, what about the processing capabilities and how they differ or
So again, coming back to architecture, right, diving deeper. So MCUs typically have a central processing unit and then you have memory, whether it's RAM or flash, and some peripherals such as GPIOs, ADCs, and communication interfaces. And digital signal controllers, on the other hand, they have a DSP functionality. So they typically have a DSP or digital signal processing engine, which accept digital signal instruction sets with dedicated hardware to multiply, accumulate, and then do complex mathematical algorithms. So use cases wise, they are quite different. And performance wise, also there's a lot of difference. For example, MCUs are more used for data management, and the DSCs are more oriented for real-time control. So it all depends on what you are using, what your end application is. Other than that, MCUs are more catered for low power application. They're optimized for that. where DSP DSCs are more for driving efficiency of the system, not necessarily for low power consumption.
Um, so maybe going into some of the software code development and tools, maybe like what are some of the differences in terms of software development tools and environments for MCUs and DSCs? And then are there any specific considerations or challenges that developers should be aware of when transitioning between MCUs and DSCs?
Sure. So I'll come to the last point that you brought up, which is about transitioning between MCUs and DSCs. So, as I said, the use cases for MCUs and DSCs are a little bit different, right? The MCUs are more catered for general purpose usage, where it's more optimized for power consumption and general purpose I/O function data management, and DSCs, on the other hand, for real-time control applications like digital power, motor control, and so on. So the choice are different, right? So uh, a system engineer would usually choose one for one set of application, the other DSC for another set of application. But there are certain places where there could be some things related to transitioning between MCU and DSCs. For example, we had a customer who was doing HVAC controller for air conditioning or the air conditioning unit for cars. uh, they were using it for controlling the motor and also communicate with the ECU. They used one higher end general purpose MCU, and then they used the DSP DSC. They saw a sudden difference of 1.5 times faster response on DSCs just because it has the right set of peripherals, which brings to the first part of your question, right? What challenges a developers may face. So when a developer is developing something for MCUs and DSCs, they need to consider that the architectures are different. So the way you configure the peripherals is going to be different. The development ecosystem might be slightly different between the two. They may or may not be interoperable. The code written in MCU may not be directly portable into DSCs due to the difference in instruction set, memory architecture, and whatnot. And other thing is the learning curve, because if you're used to one and then you have to transition to another one, you have to go through some kind of learning curve. That is where manufacturers like Microchip come into play to help them with that learning curve with development kits, evaluation tools, and reference designs.
And then are there any emerging trends or developments that may impact the choice between choosing an MCU or DSC now and maybe in the future? And then is there anything that we can maybe expect from Microchip from these two technologies going forward?
Sure, that's a very good question. So both MCUs and DSCs, as I explained, are very important and for electronic system design, and they are playing pivotal roles there. And there are a lot of emerging trends which are actually impacting both MCUs as well as DSCs in some similar ways in one aspect and different ways in another. So some emerging trends that we see is people are trying to integrate more functions into the whether it's MCUs or DSCs. The functions that they typically integrate in MCUs are more like the communication, more GPIOs, more peripherals on the analog side. Um, for DSCs, it is more analog specialized peripherals, more of your wired communication as opposed to wireless, and then enhancing the real-time processing capabilities. The other trend that we see is integration of at the peripherals and having more development tools or ecosystem. So what we see is big DSCs are more catered for power, the digital power, as well as motor control applications, as well as some robust touches and sensor interfacing. MCUs, on the other hand, are more focused on IoTs as well as IoT application, medical application, where it's more about reading sensor, processing things, and managing data and do housekeeping functions. So this is where I think we need to see how they are impacting. The last but not least is about model-based designs, because people do not want to write thousands of lines of code. And that's where I think MCUs and DSCs both are streamlining their development, catering towards model-based designs. And coming back to your question on the what Microchip is doing, so we are working on expanding our ecosystem for both MCUs and DSCs. We want to achieve the highest level of safety and security. As you can see, that functional safety is getting important for automotive, for industrial appliances, and so is security. There are new standards for security that are being released right now. So we are expanding our ecosystem. We are expanding our development tools for both MCUs and DSCs, as well as expanding the tools to support model-based design so that we can cater to these emerging trends in the market.
Next, here's Dr. Moritz Neukirchner, Senior Director of Strategic Product Management for Software-Defined Vehicles at Elektrobit, discussing open source and software-defined vehicles.
So the first question is, what are the challenges that your team faces when deciding whether you should build or buy a technology? The classic question, build versus buy.
For us, it's a lot of times also more in the direction of open development or closed development. For us, it's the question of how do we want to engage and what kind of need do our customers have to change the software to interact with us quickly? What kind of iteration cycles do they need versus what's the needs on liability, on stability, on maintenance requirements? And this is where things differ for us quite a bit.
Okay. What's the most exciting part about open source for you and your team?
I think the coolest part about it is that you actually have a completely different mode of operation compared to the classical automotive supply chain. I mean, back in the days, we had requirement specifications thrown over the fence. And you started working on them, and of course, requirements change over time. And we're now in a state where we are way closer in collaborating on source code, and you're just connected a lot closer, and it goes more towards development partnerships rather than a classical supplier relationship. And I think this is one of the major transformations that we now see in the industry.
What are the challenges that you've encountered when collaborating with other organizations on these very complex projects?
In the big complex software projects, talking about high performance controllers, talking about automotive OS, so the software platforms for software-defined vehicle. Really, we are dealing with an extremely fragmented supply chain in automotive. So we have so many different stakeholders that need to interact, that have different interfaces. Every customer has a specific setup for CI/CD, for test tooling, and this just introduces a lot of complexity and interaction. This is one of the key points, getting to automate a lot of these interfaces so that we stop having lengthy delivery chains. And this is one of the biggest challenges in getting to speed in these fields.
Do you currently use open source as part of your offerings?
Yeah, sure. So EB Corpus Linux is obviously open source based. I mean, it's a Linux system after all, but also our hypervisor, EB Corpus hypervisor, is based on open source. So that's an L4 based hypervisor technology, but we also actively contribute. So Holger's here within Eclipse SDV, we have the Ankaios project where we have a container orchestrator. So this is something that really is important to us, and we push on these consortia forward.
Okay. What do you see as the amount of use of open source in the future? Do you think it'll be more or less or the same, and why?
I think it's going to increase, but there is a couple of challenges that have not been properly addressed yet. So when I look at the governance of open source projects, the bylaws of open source projects, if you want to make open source successful, you need to be able to actually put it in a professional context later on. When we look at automotive, we have stuff like ASPICE, we have safety requirements, we have liability requirements, we have requirements on maintainability. And these requirements are a lot of times not properly reflected in that legal framework around open source projects. And this is the major hurdle to actually get something into productive use and actually building a thriving community.
What are your expectations of the future of the electric vehicle industry?
So looking at electric vehicles, I do still see this picking up. I mean, obviously we see the numbers out of China. Increasing a lot, increasing faster than in the other markets. I would expect that, especially in the light vehicle fleets, this will way stronger increase over the next couple of years. Looking at commercial or niche vehicles, well, I'm not sure in how far really electric trucks are going to be suitable big time on a larger scale, or whether we will see different technologies in that scope.
Okay. Same question for software-defined vehicles.
Right now, I think we have reached the tipping point on the hype cycle. Last year was a lot about clarifying terminology. I mean, I've spoken in so many places and written about it quite a bit, and I started writing that newsletter. I'm not sure whether you've seen that, the Automotive West Perspective. And in the beginning, a lot was about clarification of scope, of terms, of what does it really mean? What does it, clarifying that a software-defined vehicle is not just about having more software in a car, but about really being able to change value propositions, these kind of things. And we have now come to a point where terminology has converged, where necessary technology is identified, and we are coming to a point where we, as an industry, need to deliver. And we see how difficult some things are, because it not only is a technical challenge, but foremost also an organizational and business model challenge for a lot of companies.
What advice would you give to a developer who's considering working on open source projects for the automotive industry?
Never forget the business impact. Never forget that for whatever you develop in open source, there must be a viable business model so that you can actually take it in production. And a lot of times, the limiting factor for adoption of open source software is rooted in things like maintainability, liability, so to actually get the necessary commercial support rather than just solving a technological issue.
Okay. What are you most proud of with respect to the software-defined vehicle?
For me, a highlight actually was receiving the Motor Trend Award at CES, that actually was looking at, first of all, having the transition from real-time to high-performance controllers, getting the stuff on the road, but also now looking at the transition from physical development on hardware now to cloud-based workflows. I think what I'm most proud of personally is being part of that transition and being able to show the first proof points that this is not only hot air.
What do you think are the most important skills a software developer needs to have today?
That's a tough one. And I wouldn't want to make it all the same. So in the end, when I look at the automotive software landscape, there's different development paradigms coming together. You need people that are capable of working close to hardware, or real-time systems, or Linux systems, or cloud-based technology. I think one of the biggest points really is that we see a convergence of a lot of different technologies into a single system within automotive. So probably one of the key points is to have some degree of systems thinking, to understand how different abstraction layers, how different components fit together and how they impact each other. This is when I look at an automotive system, what is one of the key challenges really is now with the transition to SDV, we are talking about systems that are updatable continuously. So it's not a one-off like we used to have in regular ECU projects. You work until SOP and then it goes into a frozen version for maintenance. We now aim to have continuous updates throughout the life cycle of the vehicle. And that means you need to have a way different look at maintainability, at version management, at CI/CD. I think these are all necessary skills that you do need to have, but not the only ones.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.